going to return a list of flippers. Now in this situation, what we want to do is for each loop, which means go through the list, and for every item in this list, run the function off of loop body. When it's done, run the completed pin. So it keeps firing up here until it's gone through every flipper, and then it will fire down here. So in this situation, what I want to do is I want to, for each of these, I want to look at the flipper and I want to check the flip type. So I'm going to get the flip type and I'm going to do a switch. So essentially I'm going to, for every element in the list, look if it's a left flipper or a right flipper. Now if it's a left flipper, what we're going to be doing is creating an array of left flippers and adding it. If it's a right flippers. So the nicest way for me to do this is going to go variable. I'm going to call this variable left flippers. I'm then going to type in the word flipper, and if it's blue, then it's correctly set up as a list of flipper references. However, what we want to do is click on this little button here to turn it into an array of left flippers. I'm now going to duplicate that and call this right flippers. And all I need to do is, if it's a left flipper, get the array and add to the array. Now don't forget when doing this that to add something to an array, it doesn't just add anything. You need to actually connect this to the array element that's being read. So I'm just going to make this a little bit neater. So that add node is now adding this current array element that we're looking at to the left flippers array. At which point I want to do the same thing for the right flippers. So connect that, oops, and I'm going to drag this in and connect that too. So now I have left flippers and right flippers getting read in. So now we've got all of the flippers being stored. The next step is for us to actually create inputs for these. So I'm going to go to my project settings by going Edit, Project Settings, and I'm going to go to Input. I'm going to click here to add an action mapping, and the action mapping that I'm going to add is called left flipper, and it's going to be bound to left control. Left flipper, left control. I'm going to add a new one called right flipper, and it's going to be bound to right control. Oops, CTRL. So we now have two keys that we can use on the keyboard for left and right flipper. I'm going to go back to my player controller, and if I right click and type in left flipper, you can now see that there's an action event that exists for left flipper, which is the input action for left flipper. And all we want this to do is when someone presses the left flipper button, we look at our list of flippers. We do a for loop on them, so for each. And all we say is we want every flipper to flip. And if they release it, we want to do the same thing, so I'm going to hit Control W and duplicate. Except instead of flipping, we want to call the flop function that we created. Now, this looks like it would work right now, however we're missing a very important step. This is very easy to miss. I'm going to hit compile and save. I need to actually create a game mode and set this as the default player controller of that game mode. So I'm going to go back to Pinball, I'm going to go to my Blueprints folder, and I'm going to right click and create another Blueprint class that's based on the game mode base. Now the game mode base is where we do all of the game mode instructions. So this is where you would do things such as calculating overall team scores, for instance. Or in this situation, what we're going to be doing is telling it that if they're playing this type of game, make sure they're using a pinball player controller. So I'm going to call this pinball game mode. And I'm going to open it up and go to the event graph. Now, if I look at this, I can see on the right-hand side that by default, it has a whole bunch of different classes that the game mode knows should exist, and they're all set to the defaults. However, I don't want the defaults. I want to set the player controller class to be a pinball player controller. I'm going to compile and save it, and then within my project settings, I'm going to go to Maps and Modes, and I'm going to tell it to use the pinball game mode. Now, upon doing so, there's really only one thing that we have left to do. I'm going to go back to pinball and I'm going to open up my player controller, and that function that we created before, detect flippers, I'm going to tell it in begin play to detect flippers, which means when my player controller first exists, look around the world for flippers. It's going to add them to its arrays, and then when the player presses a button, flip or flop accordingly. I'm going to now hit play, and you can now see that my flippers are going up and down. They're also incredibly slow. So I'm just very quickly going to change that value for flip time, which by default was 0.2. I'm just going to set its default to 0.02 as a quick test. That was probably too quick. We've now got ourselves the basics of a game. I'm really quickly now going to go into my pinball controller, and much like with the left flipper, I'm going to go through and create the right flipper. I'm just going to Control W across that entire function. If you drag right flippers over the top of left flippers, you can actually change it from the left flipper to the right flipper array node. I'm now going to go input, right flipper, and I'm simply going to tell this on pressed and on released, do this. And now, we have ourselves the basics of the game. Again, flip time I'm not entirely happy with, so I'm going to tinker with these numbers and find something good. I advise you to do the same, find something that works best with the environment that you've set up, and we'll go from there. So now that we have flippers and bumpers working, it's time for us to move on to the next dynamic element, which is the plunger. So we want to actually add that piece that launches the ball into the game. Now, in doing this, we're going to need to expand our level just a little bit to have that initial channel that the ball moves through. Upon doing so, we're going to then work on actually importing the plunger, as well as setting up all of its functionality, so that when the player holds down the spacebar, the plunger charges up, and upon release, it fires the ball away. So to begin with this, I'm going to go into my assets folder, and I'm going to import the plunger mesh. So for this, I'm going to again just keep all of the defaults. I'm not going to import materials or textures, and just keep it as it is, and I'm just going to click import. Now upon importing it, I'm going to open it up and just quickly check out the collision, because the thing with the collision here is that we really only need actually kind of a box collision around it. It doesn't need to be this full shape. And the reason for that is I want to make sure that the thing that's launching the ball is never going to have any potential to hit an edge around the outside of this front part here. So I'm actually going to remove the collision that we generated. I'm going to go collision, and I'm just going to add box simplified collision, which adds this for us, which in this context is going to work quite well for us. I'm going to hit save. And now I'm going to quickly modify the map. So at the moment, if we were to launch the ball, it would need to be in some sort of channel on one side. In this situation, what I'm going to be doing is adding a channel just along here, and we're going to expect the plunger to be around this region here. So to do this, the quickest way for me to do it is to get this box that we've already created, and I'm just going to go ahead and expand it just a little bit in geometry mode. So I'm going to click on this edge, and I'm going to pull it out 50, 100, 150, 200 units, just in case. That should be nice. Now we can see how thin the ball itself actually is. I'm going to just use this, since it's in the map at the moment, to kind of size up how wide the channel really needs to be. My gut says we may need an extra couple of centimeters on either side, just in case. So I'm going to go and have a channel that's to within about 10 or 20 units of either side here. Maybe a little bit more. So we'll quickly carve that out. Again, I'm going to do a subtraction brush. So I'm going to get box geometry. I'm just going to drag it in. The quickest way for me to handle this is actually just going to be subtractive and then move it sideways and figure out where we want this to be. Now, that actually works surprisingly well as an initial default value. So, I'm just going to roll with that. Now that that's in, I'm going to get that, and I'm just going to drag this down to the length that we want it to be. I'd say we probably want our plunger to start about there, and we really want that ball to get ejected at the very top. So I'm going to put that here. Finally, I'm going to need to make sure that when the ball comes up, it's going to come out this no matter what. So we really want to make sure that the edge here is going to be in some way, shape or form slanted so that it can eject all the way out. Now there's a couple of different ways that we could do this. I'm going to start by just extruding this face here. I'm going to push it out about this length. And again, I'm going to click here. I'm going to pull this out just so that it connects. Now, I think the quickest way for us to get an extrusion is actually going to be to delete these two vertices. So I'm going to delete them. At which point I'm going to look at this and I'm going to now make this area that we just deleted into a face. So I'm going to control click on each of these. And then I'm going to hit create. You'll see that that's now gone and created a face for us. So we can now, this should go up. This area could actually still be a little bit slanted, so I'm tempted to broaden it up just a notch. So I'm using the Alt 2, 3, and 4 keys to cycle through those modes here. Yeah, I'm just going to move this back just a notch. There's a couple of different ways I could do this, but the quickest is going to be to just select this face and pull it back, just to make sure that we've got a nice opening for it to pop out. I'd say that's alright. That'll most likely do the trick. It could have even been too much, and I could just be being paranoid, but we'll see. So the next thing that we're going to need to do is actually add in some sort of plunger blueprint into this section just here. Now, to add a plunger blueprint, I'm going to go to my blueprint section, I'm going to right click, and I'm going to create myself a new blueprint class. And this is going to be an actor, and I'm just going to call it BP_plunger. Now, fortunately, this is going to be a reasonably simple setup. All I need to do is go to my event graph. I'm going to create two events called charge plunger. Well, sorry, custom events. I'm going to call it charge plunger. And I'm going to make another custom event, which will be known as stop charge. So these can be called from the player controller later. Now, upon doing this, when we go charge the plunger, we want to fire up a timeline. And this timeline is going to be called charge timeline. Now, essentially what it's going to do is gradually move the plunger further and further back until it's stopped into a location. And then when they hit stop charge, we're going to go ahead and do a move component to the initial position over a very short period of time. So charge timeline is going to have a float output that gives it a alpha between starting position and ending position. So I'm going to open this up. I'm going to add a new float track that's just going to be called charge alpha. And this should be reasonably simple. I'm just going to right click and I'm going to right click here. I'm going to add a key. And the first key that I add is going to be at 0, 0. And then the next key is going to be 1 second in. We can be at 1, 1. Just ballpark figure. Now, keep in mind that you probably want this to be set to auto, so click on a face and hit 1 and 1, and it'll just do that with the keys. If you wanted to have a more custom setup, I could also add more keys in the middle to kind of like make it move quicker at the start and then slower towards the end. Another way to add these keys is to shift click. So I could add this and I could have something that was more like that, you know, we can tinker with it in whatever way we really see fit. Doesn't matter too much here, so go with whatever you think is going to be good. I'm going to go back to my event graph now, and it's at this time that I need to go to my viewport and add a static mesh, which is going to be the moving component. So this is actually going to be called plunger mesh. And I'm just going to set this up to be my plunger. And if you look at this, we essentially want to, as it charges, to move back to here and then fire up again. So to do that, I'm going to go to my event graph, and I'm simply going to do a blend between, just going to take a shot in the dark on how this is going to work, but we're going to lerp a vector between two locations. So this will be 0, 0, 0 is when it's at 0 alpha, and 0, 150, 0 is going to be when it's fully charged. And all I'm going to do is every time this goes to update, I'm going to set the relative location of the plunger mesh. And now that that's hooked up, I'm pretty much good for the creation. This isn't going to have a sound effect or anything like that, but that's okay. Now I'm just going to say that when you go to stop, we're going to do two things. First off, we're going to do a sequence, and the first stage of this sequence is going to be to stop this charge. The next stage is going to be a move component to on the plunger mesh. So I'm actually going to drag this in, control click, and I'm going to type in move components to, and I'm just going to move it to 0, 0. So to do that, I can just leave all of these as default, and I'm going to say I want it to move there in 0.1 seconds. Sounds good. Compile, save. Now the final part in getting this working is just going to be going back to the project settings and adding myself a new bind to handle this. So I'm just going to add an action mapping, and it's going to be called plunger. And by default, I'm going to bind it to the spacebar. And now if I go to my controller, I'm going to set up how this functions. Pinball player controller. I'm going to right click and I'm going to go input plunger. Now if you think about it, to do this we really need a reference to the current plunger. And the nicest way for us to really do this is actually going to be in that initial function where we have detect flippers. I think it's a good idea for us to create another one that is detect plunger. So I'm going to create a quick custom event, detect plunger, that is just going to do a gets all actors of class. So it's going to look for every plunger in the world, and we're going to get the very first one that it finds because we don't need any more than that. And I'm going to promote that to a variable called plunger. Now bear in mind that if you do it this way and there's no plunger in the world, when you press spacebar it will throw a error because it's not going to know what to do, because this variable will be set to null if there's nothing in this array. We can fix that with validity checks, or we can fix it with print strings and log messages, but I think for the time being we can leave it and just acknowledge it as a potential thing. So the plunger is going to, on pressed, it is going to call charge plunger, and on released it's going to call stop charge. So the next thing that we need to do is make sure that our detect plunger function is being called on begin play right after detect flippers. So I'm just going to call detect plunger, and then we really just need to add the plunger to the world. So I'm going to drag that in. I'm going to make it considerably bigger. That's probably too big. 6, I guess. That'll do. Let's have a look at how that goes. Going to add that just very quickly, and I'm going to make the just aligned, sticking out of the end here. And now we should be detecting the plunger. Upon doing so, we're going to be trying to charge it and stop it. One thing that's worth noting is that if I go to the plunger, at the moment this is my setup, and this is actually going to cause a problem because if I charge the plunger, it's going to play the timeline. And when it plays the timeline, it's going to update its location, and that's all going to be fine. Eventually we're going to stop it, and then it's going to call stop and push it back somewhere. But the timeline will still be in a different location, so that when I hit play next time, it's actually not going to play from where it should be. It'll play from halfway through the timeline. So what I'm going to do instead is I'm going to control click on play and connect that to play from start instead. And now compile, save, play. I can charge up and I can fire into the game, at which point I can then play it. Now that we know it works, there's really only one thing to do, which is to go to assets, and I'm going to load up the plunger, and I'm just going to set its material to be a simple metal. I'm going to save it out, and you can see now that the material is being applied. So if I hit play again, everything works fine. So let's move on to the next section, which is going to be actually setting up all of the game rules so that the ball correctly resets. after it makes this mistake. So now that we've created our plunger, let's step through what we need to do for our game mode. The game needs to be able to create a ball, the ball needs to hit the plunger, we launch it, and then it starts bouncing around, at which point eventually the ball's going to end up in this area over here, be destroyed, and be reset. Now, that means that we need a few things. The first thing that I'm going to do is I'm going to create a position that we can get from the plunger that allows us to set where the ball is going to spawn. So we're going to establish a position in space that we can just have a simple widget that says where the ball will begin, and the game mode is going to look for that anytime it needs to create a ball, because us just beginning with the ball in play isn't the best move. So I'm going to open up BP Plunger, and within BP Plunger I'm now just going to add a variable. This variable is going to be called ball location, and I'm going to have it set to be a vector type. Now, if I hit compile and save, and I look at the ball, if I look at the plunger here, everything looks normal. However, if I go back to this and I enable this option for editable, followed by show 3D widget, I'm now able to hit compile, and if I look at this, I can now see that the plunger actually gives me a little widget that I can put anywhere in the world. Now this is very, very useful for me to use. However, I am going to change something. I'm going to set the default value to be around 400. Compile, save. Now, in this instance, this allows us to set the exact location that this ball will be created anytime we want to use this. Now, we need to go ahead and set up one other thing. This vector is storing its location in what's called relative space, which means it's storing it at a coordinate that is the distance from the plunger. However, we need to actually make that into a world position if we want to use it within the game mode, because the game mode needs to know where in the world to spawn it, not where relative to the plunger. That's rather simple to do. I'm now going to create a function. I'm going to go add, and I'm going to call this get ball spawn location. Now this get ball spawn location is going to return one thing. It's going to return the position in the world, so it's going to return a vector that the ball should spawn at. And I'm just going to call that ball spawn lock. Now the other thing that it needs to do is, if I go back to my event graph, these types of functions and these types of functions are different. This type here that doesn't require an exec pin is referred to as a pure function, and that's essentially what we're going to do. We're going to create ourselves a pure function because it doesn't really need to have an exec pin. Things just need to look it up. So to do this, what I'm going to do is I'm going to get the ball location, and then I'm going to run a transform on it. I'm going to run a transform location. Now, with the transform location, how it works is if I read in the transform of an actor, it will then put that into world space. So it gets a relative location, given an actor's transform, it puts it into world space. So for that, all I need to do is get the actor transform of the ball plunger, and then plug that into BP ball spawn. I'm now going to hit compile and save, and I'm going to go ahead and open up, actually before I continue, I'm going to delete this ball from play so we have no confusion. Now I'm going to go through and I'm going to open up the game mode, and all I'm going to do is click on this button that says open full blueprint editor. Blueprint defaults back to this setup if you've never actually added any graph nodes, so don't be too confused. So open full blueprint editor, and within here I'm going to create a custom event that's going to be called spawn ball. Now spawn ball is going to get called on begin play, so I'm just going to call that there. So spawn ball is going to get all actors of class of type plunger. It's going to get, if we wanted to spawn multiple balls because of multiple plungers for some reason, we could actually use a for loop here as well, but I'm not going to. Now I'm just going to run the function that we created, which was called get ball spawn location. So at the moment the function looks like this. However, if I delete it, I open up my plunger again, and in this function I tick this checkbox that says pure, compile. I now look at the game mode. If I drag off of this again and type in get ball, you can now see that this is a pure function. So all I need to do is I'm going to drag off of this, and I'm going to call spawn actor from class. What we're going to spawn is a BP ball. And now I need to give the ball a transform. In this situation, I'm just going to split the transform struct pin, and I'm going to connect location to location. Rotation can stay 0 and scale can stay at 1. I don't mind. Now, purely for the sake of testing, I'm going to hit compile, save, and I'm going to play the game. And you'll see that we now have a ball in the game. Now that we know that the ball spawning works, let's go ahead and handle its destruction. When the ball gets destroyed, we want to spawn a new one. Now, in the long run, we're going to be checking how many balls they have left and whether they're allowed to do this or not. But for the time being, let's just do the very simple way. I'm going to drag off of the return value of the spawn actor, which is a reference to the ball that it just created. And again, I'm going to type in bind event destroyed. This is caused by an event dispatcher, which allows me to essentially get a message from the ball when it gets destroyed. So we're going to create a delegate. I'm going to drag off of event, and under add event, I can then add custom event. And you'll see that it gives me this, which is going to be on ball destroyed. It's just a good enough name for it. And all I'm going to do as a quick test is when the ball gets destroyed, I'm going to call spawn ball. Compile and save. Now the next thing that I need to do is find a way to destroy the ball. So I'm going to go back to my world, and I'm going to create a new blueprint, just very quickly. New blueprint class, actor. This is just going to be called ball reset zone. Now my ball reset zone is going to have one thing in it, which is going to be just an overlap component. So I'm going to go into here, and I'm going to add a box collision, and this is going to be called ball overlap region. I'm actually going to make it the root as well. So now that that's in, I'm going to go to my event graph, and on actor begin overlap, I'm going to test if the thing that we're overlapping is a ball. And to do that, I'm going to do a ball cast, so cast to BP ball. So now when something overlaps this zone, it's going to say, hey, is the thing that's just encroached on me a ball? And if it is, let's just destroy it. I'm going to hit compile and save, and then I'm going to quickly add one of these to the world, which is going to sit right there. Now, if I want to, I can scale this and modify it as I see fit. In this case, I want to stretch it out. It should be fine. I'm going to lift it up a bit just in case as well. Save, play. And now I'm quickly going to test it. So we can see that that works perfectly. The ball got destroyed, and then a new one spawned instantly. So now we have an infinite game of pinball that has no ability to keep score, but we're going the right direction. Let's start looking into getting a functional game mode. We already have the ability to spawn a ball and respawn it, but let's actually start getting a score being calculated and also getting a basic UI up and running. So to begin with, let's work out how to get a score going. I'm going to load up the game mode class, and within here I think it's a good idea for us to look at adding a new function that's going to be the add score function. Now realistically we could at any stage have just a variable inside of the game mode that is the current score. However, it's a good idea for us to have an add score function so that if there are multipliers or anything like that contributing to the current score, anything that wants to increment the score simply reads in the current number of points, the game mode assesses the number of multipliers and anything else like that going on, and goes from there. So I'm going to add a new function. This is going to be called add score. And for this we're going to need a couple of things. So to begin with, we're probably going to want an input that is a float, and this input is going to be the points to add. Now, upon add score getting called, we're going to be having to get the score, multiplying the current points to add against a multiplier value, and then we're going to add that to the current score and set the current score to be that output value. Now that means we need two things that we haven't already created. The first is a score variable for us to add and check. So this is going to be called score, and it's going to be a float. Now, after we've got the score, we're also going to want to have something for a multiplier. Now, even though it's likely that all of our multipliers will be like 2 times multiplier, 4 times multiplier, 8 times multiplier, it's probably a good idea for us to make this a float as well, just in case. So I'm going to make a variable called multiplier. I'm going to hit compile, and I'm going to make sure that my multiplier by default is set to 1, because if we set that to 0, we're going to have some real trouble. So I've got my score and I've got my multiplier. So all I need to do is get the points to add, multiply it against my current multiplier, so it's going to be multiplied against a float times float, at which point I'm going to drag in multiplier. I'm then going to get this, and I'm going to add this to my current score. So I'm just going to hit plus, and you'll see that we have float plus float. And again, I'm going to drag in the variable and connect it to here. We now have points to add times multiplier plus the current score is going to be equal, and I'm going to drag this in, and I'm going to hold down Alt, so it's a set function, is going to be equal to score. Now that we've done that, it's probably a good idea for us to have an output function so that anything that's adding the current score also has the ability to see what the current score has now become. So I'm just going to add a new output, which is going to be a float, and the value here is just going to be called new score. I'm going to plug this in over here, and I'm going to connect the output of my set to the output of my function. Compile and save, and we now have a working add score function. So it's now time for us to go ahead and work out a way that we can add some score to the game to begin calculating. So I think a good way for us to begin with this is for us to go to the bumpers and just make them add 10 points every time. So I'm going to open up the bumper class, and I'm going to look at this initial bump function that we have going on that adds an impulse. At the moment it adds an impulse, it then spawns the sound attached, at which point it goes through this entire bump loop to make the animation. So it's probably a good idea for us to, before we play the animation, increment the points at about this area here. Now if you think about it, to add the score, we need to get the current game mode, we need to cast the game mode to be a pinball game mode, because that's the only game mode that has the add score functionality to it, and then we need to add some score to it. So to do this, I'm going to right click here and I'm going to get the game mode. At which point I'm going to cast to pinball game mode. Now this could be converted to a pure function if we wanted to, but just in case, I'm going to drag this up here and I'm going to set this up such that if it fails, it goes ahead and does what it normally does. So cast fail calls play from start. However, if it succeeds, we're going to get this and we're going to call add score, and we're going to add 10 points. Now the other thing that I'm going to do, purely as a quick testing variable, is I'm going to print the current score to my screen so I can see it. So I'm going to drag off the exec pin and type in print string. I'm now going to connect this to the play from start. And finally, I'm going to connect my input string, which at the moment is going to say the word hello, to my new score. And it's going to automatically convert from new score to a string and should just put a number on screen every time something is hit. So I'm going to hit compile, save, and then I'm going to play this. You can see in the top left that we just got 10 points, 20 points, 30 points. So the system's working. That said, we are going to have some issues later on when we need to reset the score. But for the time being, this is enough. In the next lesson, we're going to look at adding a UI to properly display this without strings. So, right now, I'm going to quickly remove this print string value and connect add score to the play from start. Compile, save, and we're done. It's time to start looking into how we're going to handle a basic user interface. For the time being, we're only going to be tracking one variable, but we'll expand this later. Initially what we're going to be tracking is the player's score. Now in the previous session we went about setting up a basic print string that was outputting the score to the screen. We removed it because it was purely there for the sake of debugging and identifying that the feature worked. But this time around, let's go ahead and create a new widget that will act as our HUD. So I want you to right click in your Blueprints folder, go to your user interface, and then go down to Widget Blueprint. Now I'm going to call this Pinball HUD, and this is going to open up UMG. Now there are two areas to UMG. You've got your designer and your graph. Now when you're in your designer, you're able to drop in buttons, checkboxes, progress bars, anything that you want. Now when you're in the graph, you're able to actually set functionality for each of these elements in the same way that you would typically set up something in Blueprint. So it should be very familiar to everyone. In this situation though, we're going to create something reasonably straightforward, which is simply going to output some text. So I'm going to go ahead and drag this text into the screen, not the text box, but the text. Text refers to visible text on screen, whereas text box refers to something that you can enter text into, for example, a high score or a name. So I'm going to drag this text block in, and we're going to set this up so that it's going to be our player score. It's just going to sit in the top left-hand corner of the screen. For the time being, I'm not going to bother customizing any fonts or anything like that. I just want to get the functionality up and running. So I want to go through a few things first though. Now, to begin with, we have this unusual flower-looking icon that's appeared that actually represents the anchor point. Now, this anchor point essentially helps us set it up so that no matter what size the screen is, this item knows where it should be relative to the ratio of its position on the screen. So if I was to put this here, and I was to change the screen size, for instance, to a iPhone 6, you can see that this is still saying that same distance from this corner. If I was to drop out and I was to go to a 1080i, you can see that it's sitting here. So this is very, very useful for us because it lets us make sure that ahead of time this is going to look correct on a number of different monitors and that elements are going to associate themselves with the screen in the correct way. Now it's a good idea for us to begin by just entering the text that we're likely to have. So I'm going to have score, space, and I'm just going to enter an incredibly big number. And this is going to show us the first issue that we're going to have, which is that our text box is only the size that it was originally dragged in as. And yes, I could drag this out, but it's a better idea for me to check this box that says size to content. Size to content is going to automatically change the size of the box as the content inside of it gets bigger, which does most of our job for us. Now we could also change the justification, but in this case it's not going to be necessary because aligning the text from the left is actually what we want to do. If we were to be developing the HUD from the right-hand side of the screen, we may want to justify it this way so that the score gradually pushes towards the center from the right-hand side, but for the time being we're fine. Now the next thing that I'm going to do is actually set this up to have some sort of text in it. So what I'm going to do here is I'm going to look at this section that said text, and this is where I entered the value. But next to it we have a nice little button that says bind. This is where we have the option to create a binding, which essentially lets us have a blueprint graph determine what this text should be. Before I do that though, I'm just going to name this to something that's a bit better than what we have as the default. So I'm going to click over here, I'm going to hit F2 to rename, and I'm just going to call this player score, just so we have something that's a bit more understandable when we come back to it later. I'm now going to create a binding on the text, and it's going to load up a graph. So within this function, we essentially have an execute pin that's going to run through and do whatever logic we want here, and it's going to output a text string, and that text string is whatever it is that we want to have in that text binding. So this is rather straightforward, and that is that all I need to do is right click and get the game mode. I'm going to cast the game mode to the pinball game mode, which is the one that we've created. Now I could do this as pure, I probably should, purely because game modes can be set up in a number of different ways. I'm just going to be very careful here, and I'm going to duplicate the return node, and on failed I'm going to return an empty string. However, I don't expect it to ever fail. Instead, I'm going to get the pinball game mode, and I'm going to get the score, which is this value here, just get score. And all I need to do from here is if I connect this to the text node, it's going to automatically convert from float to text. So this would put the number on screen by itself. However, there is another slightly nicer way for us to do this. I'm going to drag off of the text instead, and I'm going to type in the word format. And we get this nice little function called format text, which essentially lets you create a string. So in this case, I'm going to write the word score, colon, space, and then anything that I put into braces, so the squiggly brackets for those unfamiliar, I can go ahead and actually have them as inputs. So I do a brace, I'm going to type in player score, and then a closing brace and hit enter, and it's going to give me this as a variable, which I can now just plug into there, and then connect over here. Now the final stage to getting this working is simply to go to my player controller, and on begin play I'm going to call a function that says create player HUD, which is going to be a custom event, and this custom event is going to be launched by my begin play. Now all I'm going to do here is I'm going to drag off of create player HUD, and I'm going to set it up such that it initially removes any widgets from the player's current viewport. So if there is a menu or anything on screen, it's going to get rid of that. At which point, after doing that, we're going to create a widget. And the widget that we create is going to be our pinball HUD. We're now going to add to viewport. We can hit compile and save, and if I go pinball and hit play, you can now see that we have the score variable on screen, and every time I hit something, it's going to increase and set itself up correctly. So that's it. That's all it takes to get the beginnings of a working HUD. So now it's time for us to finish the game loop. So to begin this, I'm going to go and open up the pinball game mode. Now within the pinball game mode, if I go back to the event graph, we currently have this very simple onBallDestroyed function being called, which just goes spawn ball whenever the ball gets destroyed. But it's time for us to start looking at putting in some new conditions here to actually set this up well. Now, this condition that we're going to be setting up is going to have to check whether the balls remaining is greater than 0, because if it's equal to 0, they have no balls left, we don't want to spawn anymore. So I'm going to create a new variable, and this is going to be an integer type. Compile and save. So I'm going to set this by default to be equal to 3. So we have 3 balls remaining. And all I'm going to do is on onBallDestroyed, what I'm going to set up is a very simple check that just checks the number of balls remaining, and if this is greater than 0, we want to spawn a ball. Now, if this is false, that means that the game is now over. So we need to set up an actual end condition here that can check the data and see whether what we have is a high score or not. So I'm going to go ahead and off of this create a custom event that we're going to call there, which is going to be called endgame. So off of this false, I'm going to call endgame, and now we're going to set this up to actually check how to handle the end of a game. So the first thing that endgame is going to need to do is check our score against the current high scores, which means we need to actually take a step back from this and start setting up the basics of a high score system. Now, to do this, I'm going to go back to my content browser, I'm going to right click, and I'm going to create a new blueprint class. This time I'm going to go to all classes, and I'm going to type in the word save, and you'll see that we have a save game object that we can base it off of. And this is just going to be called high score save. Now within the high score save, what we essentially need to do is set up a simple variable that will be storing our list of current high scores, and then we're going to be iterating through that. Now, one of the nice things that Unreal lets you do is not only do we set up basic variables when scores are saved out, but we can also add some simple helper functions that make our lives easier when we want to work with these in the future. So to begin with, we're going to need to create a variable, but if you think about it, we need to actually store more than just one, because we don't want to just store a number, we also want to store a name, which means not only do we need to create a high score save, we also need to look at creating a struct. So once again, I'm going to go back to my pinball project, I'm going to right click, and this time I'm going to go ahead and create under blueprints, you'll see this section called structure. And this is just going to be called high score struct. So when I double click on this, essentially it lets us add as many variables as we want to one section that can all be tied to each other in a single data type. So I'm going to get this, and the first thing I'm going to create is going to be called a variable called name, which is going to hold text. The new variable I'm going to create after that is going to be called score, and it's going to be of type float. So if I go back to pinball and I open up my high score save again, you can now see that if I add variable and I set this to be save struct, I can now, under the variable type, you'll see that high score struct is actually an option. So I'm going to create that, and I'm going to make sure it's an array. This way we have an array of structs. So we have a list of high scores, essentially. So we've set up our in-game data types. So now let's go ahead and look at actually setting up some additional functionality too. So under functions, I'm going to create a new function that is going to be used to determine what the current lowest score in our high scores list is. Now the reason we're using the current lowest score is we want to check whether something is even worthy of making it into the list at all. So I'm going to create a new function, and this function is going to be determine lowest value, score value. Now this function is going to go through our entire loop, so I'm going to drag in my save struct and set up a for each loop. And all it's going to do is it's going to check the score of each one of these structs. Now you'll notice that at the moment when we see this struct being accessed, it's not showing both of our variables. Instead, it's only outputting the array element by itself, which is the structure. Now there are two ways that I can go ahead and access the information within this. I can either drag off of this and click on break, or alternatively, I can right click on this and I can select split struct so that these variables are both exposed now. So to get this working, because we're just getting the current lowest score, we also probably want to save the lowest index just in case too. I'm going to go ahead and create two local variables. The first one is going to be called lowest score, and the second is going to be called lowest index. Now to do this, all I need to do is I'm going to set lowest score to be a float variable and lowest index to be an integer. I'm going to make sure that they're not arrays, which is currently the default because of the last time we created a variable. Let's do a quick branch. Now, if the index is equal to 0, which means if this is the first time we're running through this loop, we just want to set the lowest score to be equal to that current index, which means the current lowest score is the first member, and the current lowest index is also the matching index for it. On subsequent loops though, this is no longer going to be equal to 0, and we're now going to be checking if the lowest score value that we've already set is less than the lowest score index that we had earlier. So to do that, all I need to do is, if this is false, we want to then do our check for the two scores. So if the current element that we're looking into is less than the lowest score variable, we now do another branch, at which point we then either set the lowest score and lowest index to be those, or we go to the next element. So in this situation, I'm going to hit Control W to duplicate. Now if this is less than lowest score is equal to this again. Now this is starting to get quite messy, as you can see. So it's a good idea for us to kind of set up some nice logical pathways to have everything set out well. So I'm going to start adding reroute nodes by just double clicking and dropping them where I should. again, for this variable, these are all accessing the same thing, so I'm going to go and pull these down to here. It's going to be pulled down to there, at which point I'm going to do the same thing with this one here too. That is, bring it down to here. It's still not amazing, but it's definitely less chaotic than it was. So again, all we're doing, if we follow this logic through, is the first time we're going, hey, is this the first element of the array? Yes, it is. Okay, set things up. The next time round, we go, hey, is this the first element of the array? No, it's not. Okay, well, is the score currently greater than our known lowest score? Yes, it is. Set it. Otherwise, go to the next thing. So now that we've finished the loop, it's time for us to add a return type. Now, we could output the lowest score, or we could output the lowest index and then access it. However, in my opinion, it's better for us to actually output the struct itself and let users access that as they want to. So to do this, I'm going to output the save struct as well as the index, which is rather simple because all I need to do is on completed, I'm going to select this initial node, and under outputs, I'm going to hit new. And this first one is going to be a struct of the high score struct, and I'm going to call it lowest score struct. And in addition to that, we're also going to output the current known lowest index, just in case we ever need to access it. So I'm going to hit new, and this is going to be called lowest score index. And this is going to be set to an integer type, at which point all I need to do is completed connects to this return node, lowest index connects to here, and lowest struct is the save struct. Hold down control. I'm going to type get, and then connect lowest index with the get and return that struct. So we've created a determine lowest score function, but let's also set up a quick determine highest score. I'm just going to right click and duplicate the existing function and just change the wording. So this is now determine highest score value. To avoid confusion, I'm going to quickly go through and just rename these variables. We now have high score and highest index. In addition to this, I'm going to change my return to be highest and highest. And finally, all I'm going to do here is in this check where we're saying if the score is currently less than the high score, we now want to say if the score is currently greater than the high score. And that's all we require to have that functioning. With our highest score value determined, let's go back to our pinball game mode and work out how we want to work from here. So when the endgame function is called, we want to load the current high scores list and see how it's all working, see what the lowest score is, and determine whether we actually belong in that array. So it means that we need one extra function, which will be used to get the current game save data. So this function is going to be reasonably straightforward. It requires a few things though. It requires a quick setup that allows us to store the current save game data as a variable. So I'm going to create a new variable just called current save object. And this is going to be a high score save object. And now I'm going to create a new function within my game mode, which is just going to be called get save game data. So when get save game data is called, what we're going to be doing is we're going to be checking if the current save object is valid. Now I could drag off this and do is valid and have it set up this way, but one thing I like doing in these situations is right clicking on it and just converting it to a validated get. So we get the save game data and we check if it's valid. Now if it is valid, then we want to just return it. Simple as that. So I'm going to add a new output, which is here. The output is going to output the current save game object. The type is say high score save, and the param type name is going to be current save object, and I'm just going to output that. Now, on the other hand, if it is not valid, so if the current save data just doesn't exist, then we want to do a very quick thing. Does save game exist? So we're going to check if the save game exists, which is going to require us to have a save game name. Now, I personally like storing this in a variable since it's the kind of thing that we pass around a bit. If you wanted, you could just type it in every time, but let's create a variable. I'm just going to call this high score save name. And we're going to quickly compile, and the default high score save name is just going to be called, let's go with something simple and just call it high score. So we're going to say, does the save game exist? Called high score. Now if that's true, then we want to go ahead and load it from the slot. So load game from slot is what it's called. So if it's true, we want to load the game from the slot. Which game? The one that we made the variable for. And after we've done that, we want to cast it to the high score save. At which point we could return the save games, or we could sort the save games and then return it to make sure that our high score list is always coming in the correct order. I personally like sorting it in this instance because we're not going to use it very often, so I'm going to set that up, and I'll show you how to do that in just a moment. Now the other thing that's worth noting before we go ahead though is to go false. Now if it is false, we want to create a save game object, which is going to be of type high score save. As before, we want to cast it to a high score save. And let's set the current save object to be equal to the high score save. Just going to set it. And I'm going to set it here. Just quickly to get the function up and running. The other thing that I'm going to do is get my return node over here. It's going to Control W and return this. Now obviously it's possible for this loop to actually bail out, so if I wanted to, I could set this up as a pure so that it's always going to push through and cast failed is never going to be an exec pin. Alternatively, I could duplicate this and just return null if either of those fail. They've got no reason to, but it's worth noting that, you know, it's possible. So with that set up, we do probably want to have a quick sort function in there. There's a couple of ways that we could do this. The easiest way is going to be setting up a quick loop inside of our high score save. Just going to create a function called sort save data. Now to sort something like this, what I essentially want to do is I want to get the current array, at which point I would then create a duplicate array. I would then get the highest value and read it into my new array, remove it from this, drop the new highest value into that, remove it from this, new highest, remove, and go through it until the array is empty. That's the quickest, easiest way for me to kind of get this going. So I'm going to add that as a simple thing. So to do that, all I need to do is set up a temporary save struct. So I'm going to promote to a local variable called temp save struct. That's good enough. I'm actually not going to set it. I just wanted to create the variable and make sure it was auto set to the correct type. And all I'm going to do here is I'm going to get the save struct, and I'm going to do a very simple while loop. So I'm going to get the length of the score, the save struct that we have. I'm going to get the length of that, and I'm going to say if this is greater than 0, while. So how a while function works is it keeps reassessing this here until it's no longer true, at which point it cancels out of the while loop. So in this case, it's going to, because we're going to be removing something from the save struct every time, it's going to keep doing this until the save struct is empty, at which point it's then going to set things up and return things correctly. Now in my situation here, my loop body is going to get the highest value in the save struct. I forgot that I actually don't even need to drag that in because it's part of our thing. So I'm going to determine the highest value, at which point I'm going to add this to my temp save struct. So I'm going to call add. And the thing that we're adding is that struct. At which point, from the standard struct array, so the standard array that we have that's holding all the scores, I'm just going to remove this from there. Type in remove index, at which point I'm just going to remove that index there. So this will very simply go through, get the highest value, add it to this, remove the index, go through, highest value, remove index, until we're all set up. At which point the only thing I need to do after that is on complete, I want to tell save struct that it is now equal to my temp save struct. So on complete, I'm going to do that, compile, save. So now my pinball game mode, if I go back to here, the thing that I'm going to sneak in is when loading the data, let's do a quick sort. So before I set it, I'm just going to do a very quick sort save data on it. And that should be all we need to have a functioning sort for our save game. So from here on in, it's time for us to actually set up the rest of this in-game condition to correctly load the save and work from there. So next up, we're going to be working on the game mode, which means we need to look at the logic that it's going through. Now initially, it's checking when the ball is destroyed, whether it can spawn another one. Now it's either going to spawn a ball or it's going to end the game. When it ends the game, it needs to do some logic based on whether it's currently setting a high score or not, and that's very important. So we're going to call the getSaveGameData function that we've already created. Now after we add this getSaveGameData, what we're now going to do is we're going to check its length. And the reason we're going to check its length is we want to see how many entries are actually in there. Because if it's below a certain number, we know we definitely want to add it. However, if it's equal to the maximum number of entries, then we want to check to see whether we're allowed to go in there or not. So I'm going to do a quick check on the length of the array. So to do that, I'm going to get the save structs, and I'm going to check its length, which returns a number of how many entries are currently in this array. Now let's say at any one time I only want to have 4 save games in there, so 4 high scores saved. I'm going to branch, and if it's less than or it's equal to 3, we know we want to add it, so I'm going to execute this true pin. However, if that's false, I'm going to check one other thing, which is I'm going to check the minimum float, which means we're going to get this, and I'm going to do that check that I had before, which was lowest score value. Just going to quickly tidy this up as I go. So I'm going to check the lowest score value. I'm going to split this struct, and I'm just going to see if this score is less than the current score, that's when we also want to add it. So both of these are going to result in us wanting to add something to the score. So what I'm going to do here is I'm going to make one last thing in my high score save, which is going to be a new function, which is just going to be called addScore. And addScore is going to have an input, which is going to be a struct that we had before, the high score struct. And this is going to be called newScore. Now, we could put the validation inside of this function if we wanted to. It's really up to us how we want to handle this. For the time being, all I'm going to do is I'm going to get the save struct array. I'm going to add this to the save struct array. I'm then going to sort it. So I'm going to call add. I can add the new score to it. At which point I'm going to sort the save data. So I'm going to drag in this function that we created before. After we've sorted the save data, I then want to get this, and I want to set the size to be either the size of 4, or if this current struct is lower than 4, to be equal to that. So either 4 or that. It'll just size up those two numbers and set it to that. So this min function pulls, if I enter two values into it, it gets me the lowest of those two numbers. So this wavelength is somehow over 4. So if it's 5, it'll drop this size down to 4. And because we've sorted this struct in order of highest to lowest, it means that this will remove the remaining things on there. So I'm going to compile, save. Now you've got to be careful here because we've gone ahead and made two functions called add score. One is on the game mode and one is on the pinball game mode. In hindsight, I probably should have named these differently. Actually, I might save that now just in case. So I might actually rename this function to be called add a high score. At this point, we need to now enter that add score function that we created. However, we do have a slight issue. We could hook it up here for the time being and drop in a quick node. However, we haven't actually given the player the ability to enter their name yet. So what we're going to do here is add a very quick widget that will show the high scores currently and give us a little text box to fill in a new one. This is purely for the sake of us having something that we can kind of work with for the time being, and we'll pretty it up later. But for the time being, I'm going to right click, I'm going to go to user interface, and I'm going to create a new widget blueprint that's just going to be called high score entry. And high score entry is going to have a text box that is going to be anchored in the center of the screen. I'm going to set its position to be 0, 0. And because this is now putting it in that bottom left corner, I'm going to set the alignment to be 0.5 and 0.5, which moves it halfway across and halfway up, such that it's now anchored dead center of the screen. I'm also going to size this to content, and I'm going to stretch it out a bit, actually, its default size. So I'm going to drag this out, and I'm going to drag this out. So for the time being, that's going to be just our entry box. And the other thing I'm going to do is add a text box that is going to output the current high scores. So it's going to be set up with an anchor point in the center of the screen. And this is now going to be set as, actually I might just center this out as well. Should be fine. So let's go here. And this will definitely be set to size to content, because this will be high scores dash number. It'll kind of look like this over and over and over again. Instead of what high scores though, it'll be someone's name. So what we're going to do here is when this menu gets loaded up, we're going to create a binding. And this text, which we should really rename, so I'm just going to set this to be called high scores list, and this can be called text entry. In my graph, all I'm going to do is get the game mode. After I get the game mode, I'm going to cast to pinball game mode. Somehow that fails, which it never should. I'm going to return nothing, but if it does succeed, I want it to return a string that is made up of the current save data. Now we can only get into this if the current save object is true, because this is going to get loaded up from that screen. So I'm going to get the current save object, I'm going to run a for loop on it. So I'm going to get structs, for loop, and all I'm going to do is create a new local variable, which is just going to be called output text, which is going to be equal to, basically we're going to run through the array, save the current line of text to a buffer, and then go to the next line and add that to the current buffer, and then add that until we're done. So to do that, all I need to do here is I need to get the current array element, and I need to create a format text, which is format text. So this is the function that we used before, that is going to be called name dash score. So see how I put those two in braces? And output text will be equal to, it'll be equal to the current output text with a new line added to it, and this. There's a couple of different ways that you can do this. I personally find that the quickest way is to do this. Is to go old, hold Shift Enter, and then type in new. This is just a really cheeky way to do it, but it works. Which is just going to go get the current array's name and score, and then add that to it. So the name and the score now gets appended into the old one, which is going to be output text. Cool. Compile, save. So that should work, and then at the end of it, it outputs the output text. That'll work as just a super simple list. And finally, the event, if back in the designer, this is going to be where they input their text. And upon entering this into the text, what I'm going to do is, so I'm going to go down the bottom, and you can see this on text committed function. I'm going to click plus, and that's going to add that. So now when they hit enter after entering their text, it's now going to do this, which is what we're going to use for our function to call the add high score. So I'm going to get this, and I'm going to get the game mode, cast pinball. I'm going to convert this to a pure because I know this has to be true at this point. I'm going to then get the save object, and I'm going to call that function that we created. And the new score that we enter into it, the text is going to be the name that they just entered, and the score that goes into it is going to be the current score of the game mode. Now this isn't going to exit out after they hit enter right now, so that's going to be a problem, but it's still going to be enough that we can see whether this works or not. So as a very quick thing, what I'm going to do here is I'm going to create a in the same way that we had that function earlier in the player controller that was create HUD, we're going to do the same kind of thing, but this is now going to be to load the high scores list onto their screen. Now there's a couple of ways we could do this. I'm just going to make a custom event here for the time being that's called create high scores list, which is going to get the current player. So not get current player, it gets type in get controller and you'll get player controller. We know there's only one of them, so I'm just going to get this cast to pinball player controller. I'm going to convert this to pure, and from here I'm going to add a I want to create a widget for it. So I'm going to type in the word widget. The widget that we're going to be creating is a high score entry, at which point I'm going to add to viewport, and in theory we're going to get something that's going to begin functioning when I plug this in. So off of this true, I'm going to call create high score list, and off of this true I'll do the same, compile, save. So now I'm just going to quickly test that. So I'm just going to let myself die. Ball goes out, new ball comes into play. And this should be my last one. Oh, okay. We're missing one thing, which is rather straightforward, and that is, at the moment, whenever we go to spawn the ball up here in onBallDestroyed, the thing that we should be doing is decrementing the current balls remaining to have one fewer. So I'm just going to get balls remaining. Now I could do balls remaining is equal to balls remaining -1, but I can also actually just type in --, and it will give me this nice little function called decrement int. If I plug that in, this will now reduce balls remaining over time. So let's test that out. So to create the main menu, I'm just going to right click and go to user interface, and once again I'm creating a widget blueprint. This is going to be called main menu, and it's going to be set up in a rather straightforward way. I'm going to have some text up top. I'm going to have a button that's going to be my main play button, and I'm going to have a high scores list beneath it. Don't really need to have anything else just yet. I'm going to anchor this. I'm going to anchor all of these to be 0 on the X with an alignment of 0.5. I'm going to put this with the same anchor so that it sits relative to it. But the anchor is going to be top left, so top middle. Zeroed out, 0.5. Going to make this quite a large piece of text. So this first piece of text that I add is just going to be the name of the game. Pinball game. You'll do. And I'm going to set this up to be large font. Again, we're going to customize this later and make sure everything looks good, but for the time being, this is really all we need. I've got this, so it's positioned to be there. Pinball game, the button itself, and now I'm just going to add some text to it. So I'm going to drag the text onto the top of the button, and you can now see that it's added the text here. So there's a couple of different ways I can approach this situation. Right now we're going to be using the button as the thing that we're clicking on, but I don't really want this button visible in the long run. That said, I'll fix that up later when we kind of do a aesthetic pass on this menu. For the time being, all I need to do is set up an on-clicked event so that when someone actually tells this to play, it'll do it. First up, I'm just going to quickly set this text box to say the word play. I'm also going to increase its size to just be a little bit more obvious. Great, and on this I'm going to go to on-clicked. Now, this is saying on-clicked for button 214. So again, we've done what we did earlier, whereby we hadn't actually named the button. So I'm going to rename this to play button with F2. And in my graph, you'll now see it says on-clicked play button. So on play, well, what do we want to do? This is where we need to actually communicate with our game mode and have something actually set up. So within my game mode, I'm going to look at what we have at the moment, and I'm going to work out the best area for us to go from. Now at the moment on begin play, we call spawn ball, and then upon spawning the ball, we do what spawned ball should do. But we never actually have a start game or reset game function being called. So it's probably a good idea for us to set things up to go with that instead. So I'm going to create a custom event just called reset game that is now going to spawn the first ball. So I'm going to disconnect spawn ball from that and instead put it into reset game. And what we're going to do here is when reset game gets called, we're going to spawn the ball, we're going to set the score to 0. We're going to set the multiplier back to 1. We're going to set the balls remaining back to 3. Now, if I wanted to, I could actually do get class defaults and then hook these up so that they enter back in there. This way, if we ever change the defaults, these will reset themselves. High score name's never getting changed, so I can leave that. But otherwise, this is a simple function that we would have for reset game. That said, spawn ball should probably be called after I set everything else. Otherwise, we're going to try and spawn a ball that's not going to work. So I'm just going to move these across. So on reset game, we're going to be doing this. And as well as this, we're going to be spawning the player HUD when they reset. So I'm going to set this up to now call from the player controller. I'm going to just copy and paste these calls that we have from before. So I'm going to get the player controller. I'm going to cast it to a pinball player controller. At which point I'm going to create player HUD, which is the function that we created before. So when reset game gets called, this is what it's going to do. It's going to essentially start the game. So now I'm going to go to the function that we created earlier, which was create main menu. I'm going to make sure that its widget is correctly set to the main menu widget. And the final element is to go up to begin play, and when the game begins, create the main menu. I'm just going to make sure that everything else has been set up. In my high score entry, after we save the game to the slot, we now want to get the game mode, and we want to create main menu. Trying to neaten things up for us. So we've now got our save game set up correctly. In theory, our game mode is also set up correctly. And when I hit play, we're now going to see pinball game as our main menu. When I click play on this button, it's currently not going to do anything because we haven't hooked it up just yet, but we're nearly there. So if I go to my main menu, on clicked, I'm going to be getting the game mode. I'm going to cast to pinball game mode. And then from here, I'm going to call reset game. Compile, save. So when I hit play, it got rid of it. Now the first issue that it's gone ahead and done is when I hit play, my mouse is still on the screen. So I'm going to make sure that that gets disabled the next time we go around. But apart from that, everything should work fine. I'm going to quickly fix this mouse issue, which is simply the same call that we had before where we did show mouse cursor. I'm now going to make sure is correctly set when we call this on the player. So I'm going to duplicate this. I'm going to plug the target into the player controller. And when we create the player HUD, I'm just going to disable the mouse cursor. So this is in my reset game function. Now the other issue that we haven't addressed yet is if I go to my main menu, into the designer, I have to go down here, and I'm just going to add that high score widget that we created earlier. I'm going to make sure that it's set up, centered from here. And from here, if I go into my pinball game mode, and I see where my main menu is initially created, which is up here, we call create main menu, which then goes down here. What we're not doing yet, that we have already done when we do the high scores list, is we haven't gone and called this get save game data function. So there's a few ways that we could do this, but the easiest way is for us to just call get save game data so that it gets correctly set. So if I was to drop this into here, compile, save, and then hit play, you'll see that all of my scores are listed here correctly now. And I can go ahead and I can play through the game. Just make sure I get a high score. There we go. And then it pops up again. Because I got a new score, I can now enter it. Person. And you'll see that that's now in there. So everything's correctly set up, and we now have a basic gameplay loop. So now it's time for us to actually start adding some more interesting score values and some far more interesting props within the world that we can use to create a more enjoyable game. However, before I do so, I'd like to change a couple of little details around here that are currently going to be causing a bit more overhead than I'd really like. I'm going to go to my high score widget and just change how this little bit is set up. Now, the reason I set it up this way was because I really wanted you to understand how bindings work and that we can output something in a nice, easy fashion, right? But the thing is that you've got to remember with bindings that literally every tick it's going to go through and it's going to reassess this to figure out what it should say. But the truth is that the high score widget only really needs to set its score when it's created and doesn't actually need to set its score at any other stage. So what I'm going to do is go to the getText function, and I'm going to rename this to just generates high score text is the new name of it. Now the reason I've done that is in my event graph for the high score widget, after event construct, which is kind of the equivalent of begin play for a widget, I'm going to drag in generate high score text, and I'm going to right click and I'm going to hit promote to variable, and this is just going to be called high score text. It's at this point that I'm going to go back to the designer for a moment, click on the high score, and where this says currently that this is bound to generate high score text, I'm just going to remove that binding, and instead I'm going to create a new binding that's going to be far simpler. So simple in fact that it looks like that. So what's going to happen now is when this widget is first created, it's going to figure out what it needs to say, and then from then on, it's just going to output that, and it's not going to keep running that loop every time. So you can see that when I hit play here, this is exactly as it should be. But this time, we're not adding all of this unnecessary overhead. Now, while it didn't matter too much here, because it was just a main menu, it is the kind of thing that can really matter when you're doing it with your actual game. So definitely keep it in mind that that's just a slightly nicer way to do some of these things. Just caching initially, and then working from there. So we have ourselves a basic win condition loop. When the game's over, it knows what to do if you've won and if you've got a high score. However, we are missing a little detail here, and that is what happens if you lose. So at the moment, if you fail to get a high score, this pin within end game never gets called. So it's a good idea for us to just add that in, otherwise you're going to have a very boring game once you lose. So to do that, all I need to do is call the function for either reset game to start the game again entirely, or create main menu. In my opinion, it's better for us to go back to the main menu and let them click play to start again. So off of false, I'm just going to drag, I'm going to type in create main menu, I'm now going to compile and save, and when I play the game and I lose, and there we have it. So when I failed to get a top score, I've gone back to this main menu, and everything is great. We have a complete loop that I can begin playing the game again straight away. For this lesson, we're going to be looking into the spline tool. It's one of the most powerful yet underutilized tools within Unreal Engine 4. So for this, I'm going to need to import a couple of extra assets. I'm going to be importing rail end, rail mid, and rail mouth, just to start with. For these, I will auto-generate collision for the time being. We'll see how it performs before assessing whether it's going to work or not. So we have 3 assets. Before going any further, I'm just going to quickly go into these and set some things up. First off, for each one, let's set the material to just be that simple metal. Next, I'm going to check out the actual collision mesh. Now this is definitely not going to do. So for this, I'm going to try generating high hull vertex collision. This is still not amazing, but it'll definitely do for the project. So in this instance, I just had to set the max hull verts up reasonably high to get something that was going to work. I mostly care about an object coming down towards this and then falling. So I'm going to save that, at which point I'm going to open up rail mid, check the collision, delete it. Let's try generating one for this as well. That'll work for us as well. So I'm going to hit save. And then I'm going to go into the last one. Oops, I forgot to set the material on this one. There we go. I'm going to go into rail mouth, which is just a slightly wider version of what we've already got. I'm going to punch up the verts, and I'm going to generate on this. Yep, that'll do nicely. I'm going to save. And now it's time for us to start generating the actual blueprint. Oops, and once again, same mistake. Simple metal has to be set. So I'm going to go to blueprints, and I'm going to start looking at how to use an actual construction script. So new blueprint class, once again it's going to be an actor, and I'm going to call this BP_rail. So for BP rail, we're first going to be adding a new component, which will be a spline. So click on add component and type in the word spline. Now there are 2 options here. There's splines and spline meshes. Now a spline refers to a shape that is the actual line that you draw through the world, whereas a spline mesh refers to a single mesh that will be kind of bent to follow a line that's given to it. You give it a start position, an end position, and the directions, and it'll try and warp the mesh to its shape. So in this case we want to add a spline, but later down the track we'll be adding spline meshes programmatically. So I'm going to add a spline, and I'm going to set it to be the root component. And this is what you will see. Now for this initial work, I'm going to get this, and I'm going to drag this out to be slightly longer and make it 300 units long. This will make a little bit more sense in just a moment. I'm also going to right click on this and add a spline point here, where I grab and I'm going to drag this up. So we have kind of like a basic arch. So if you missed what I just did, I right-clicked and I hit Add Spline Point here. And this is the shape that you should have on screen. Should be reasonably straightforward. So I'm going to hit Compile, Save, and I'm going to go to my construction script. Now essentially what I'm going to do here is I'm going to go to my construction script and I'm going to run a for loop. Now this for loop is going to do something that is, it's going to look at this spline and it's going to calculate how many of these points there are in it. Now at the moment we have 3. And for every point that's in there, what we're going to do is iterate through and add a mesh that connects to the next point. Now what this means is that we don't want to count the last point because it doesn't have a point beyond it. So we actually want to do the length minus 1, which means if we're doing a for loop, we're not actually doing length minus 1, we're doing the number of points minus 2 because the index is 0, not 1. So we're counting from 0 instead of counting from 1, which means we get a reference to the spline, we get the number of points, at which point we subtract 2, and I set the last index in our for loop to be the number of points minus 2. Then, for each point, what I need to do is add a spline mesh component. Now for this spline mesh component, what I'm going to be doing is I'm going to be setting this to be the rail. For the time being, I'm going to set all of them to be the rail mid, but I'll work on some better behavior in a moment. So we have the initial spline mesh component. However, we need to go ahead and actually set the rest of this so that it correctly warps along the spline. Now this is where we start looking at the start and end. So I'm going to get this spline mesh and I'm going to drag off of it. I'm going to type in set start, and you'll see that we have a nice function called set start and end. And when we get this, it actually gives me a start position, start tangent, end position, and end tangent. And we need to set these to correspond with our actual mesh, which means what we need to do is, we can just give myself a little more room here. What we need to do is get the point on the spline that we're looking at, get its position and tangent, and then get the next point on the spline that we're looking at and get its position and tangent. So the nice way that we can do this is to actually get a reference to the spline, get point, and you'll see that we have a couple of things here. We have get location and tangent at spline point, and all I need to do is say at the point index, set that to be the start and the tangent. Now at the index plus 1, I'm going to duplicate that and reconnect the spline. At the index plus 1, I'm going to set that position and tangent. At which point, all I need to do is hit compile, save, and if I look in the viewport, you can see that it's actually getting this mesh and it's warping it along it. And if I was to hold down Alt while dragging this out, I'd be able to actually draw a bigger spline into the world. Now I'll show you that in the actual stage. So I'm going to get the rail, I'm going to drag it into here, at which point we see this. Now if I click on the spline ending here, I go to my translation widget and I drag it to here, you can see that I'm actually able to kind of move along the spline. I can alt drag to bring in new points, but I can essentially make some really interesting shapes that we can use to kind of feed the bumpers within the game. If I hit go, this is what we would see in this case. So I could set up some really cool stuff that if the ball kind of came into here, it would then roll through and then drop out and do whatever it wants. Now, to get this working well, we need to consider doing a couple of extra things. Now, the first thing that I'm going to do is I'm going to go back to my construction script, and I'm going to look at this spline mesh component, and what I'm going to do instead is I'm going to do a quick check. And what this quick check is going to do is it's going to see if the piece that's there is also the index 0. So I'm going to see if the current index is the index 0. And the reason I'm going to do that is because if it is the index 0, I actually want to set the scale to be a different mesh. So we can have an intro piece, and we can also do the same thing with an outro piece. So we can set the static mesh according to whether it's the first position, the last position, or if it's the mid position. So I'm going to get this spline mesh component, and I'm going to add a simple branch. I'm going to open these up and just pull them down a bit. And all I'm going to do here is, my first condition is checking if it's the first piece. So it's going to be saying, is this index equal to 0? Now, if that's true, what we want to do is set the static mesh for this. Space that out just a little bit. We're going to set the static mesh for this, and then continue with what we would normally do. And the static mesh is going to be equal, I'm going to promote this to a variable, rail start mesh. And I'm going to set this to be the rail mouth. Now, if this is false, let's then check to see if it's the end piece. And if it's the end piece, we'll do an operation on it as well. So, how do we check if it's the end? That's simple. All we need to do is check if this index is equal to the very last piece that it's going to check through, which is equal to that. At which point, I'm going to duplicate my branch. I'm going to connect this to here. And if this is false, I'm going to set the static mesh. So I'm just going to duplicate this. If that's true, I'm going to set the static mesh of this component to be equal to, oh, it's getting a little bit messy, I should really clean this up. Just going to add a reroute note there and kind of connect it that way. And if this is true, what we want to do is promote this to a variable, and this is going to be called rail end mesh. Compile. I'm going to set this to be rail end. And if that's true, we're going to go straight on through and connect that. And the last piece that I'm going to do is, if this is then false, we're going to set the static mesh to be equal to the general mid piece. So set static mesh. We're going to set the mesh of this target, so that's hooked up. So if that's false, this will then connect through to here. And I'm going to promote this to a variable, which is just going to be called rail mid mesh. Compile, save. And if I look in the viewport now, you can see that the end has this shape. So if I look at what we've got here, oh, I missed a piece. I'm going to go back to my construction script, and I'm going to set the default variable for the rail mid mesh. Compile, save. And if I look at this in the world, I'm going to go into unlit so you can see it a bit better. You can see that this opening has that wide section that we had created for that first mesh, and that the end section now has this cap on it, which means if I wanted to, I could actually have this up here and the ball would still fall out. Which would be some nice behavior, because it would go and then drop. So that's the first section, but let's actually get this working a little bit nicer. There are going to be two extra little features that I'm going to add. The first is that if it's the rail start mesh, I want to have the ability to set a custom scale for the mouth of it. So to do that, all I need to do is get a reference to the current mesh component that we're looking at, which I can get from here. So I'm going to get this, and I'm going to set scale, and I'm going to set the start scale if it is the start mesh. So I'm going to plug that in and plug this into here. Now, since that's quite messy, I'm just going to add a reroute node, pull it up and over, and all I'm going to do here is I'm going to split this pin because it's looking for an X and a Y, but realistically I only really care about making it wider. I don't really want to make it taller as well, just wider. So what I'm going to do is I'm going to split that, and I'm going to create a variable. So right click, promote to variable, and this is going to be called initial scale, and the default value here is going to be 1. Now the next thing that I'm going to do is I'm going to set all of these variables that we've created to be editable. The reason for that is that by making them editable, I can now modify them from the default properties over here. So let's have a look at what happens when I change these. If I set initial scale to 2, we now create a much wider initial section for the rail to potentially fall into. Sorry, for the ball to potentially fall into. So the ball's going to hit that, and then eventually it's going to get funneled into the rest of it. Now the other cool feature about this is, if I go to my assets and I were to get some of these other assets, such as plastic ramp and plastic ramp end, as well as general ramp. So I'm just going to import all with default settings. Now with these meshes imported, the reason this is super useful is that if I wanted to, I could set these, just type in the word ramp, and I could set this to be the plastic ramp normal, at which point we've got this. Or I could set it to be the version of it that has, type in the word ramp, so I can see them all. I could set this to be the no-top version, and then I could set the mid pieces or the end piece to be their own thing as well. So if I go to here, ramp, I could then set this to be no top, at which point we end up with this nice thing where the ball could roll in and then fall through, and it looks like it actually belongs on the stage. And it's something that we can easily then just expand on and modify and do all sorts of weird and wonderful things with it. So again, I can just click there, I can alt drag, and we can have some interesting setups, which is nice. All I need to do to really complete this feature is to set the materials on each of these three things, which I'm going to do very quickly, and set the collision for them. So by default, if I want to look at these, I'm going to quickly check out the collision, which I can see is wrong. I actually don't care about the collision on the top, so what I'm going to do is, for the time being, I'm going to disable collision on the top, and then I'm going to go collision and generate. Actually, I might just try 16, it'll probably be fine on this mesh. Apply, which will generate that. I'm going to re-enable collision, at which point I'm just going to quickly set the materials for each of these things. I'm going to set the roof to be white, I'm going to set the body to be yellow, save, and then I'm going to quickly run through and do that on the other meshes too. This can just be yellow as its general color. The other thing that I'm going to need to do again is check the collision. It's definitely wrong. I'm going to just do an auto generate off 16 as well. I'm going to save, and finally I'm going to go for the ramp end, which is this one. Oops. Should be yellow. You should be white. Show my collision. Gonna delete that. And the one I want to get rid of is this one for the time being. Apply. And now you can see that we can have something that'll drop straight through. And we should be all set up. So the last thing that's super important when you set this up, that's very easy to miss, is go add spline mesh component. And I want you to go down here and look for the word collision, because by default collision presets are no collision. Instead, I'm going to set this to block all. Compile, save. Now, when we want to test this at the end, I'm just going to drag in a ball so that we don't actually have to do any extra testing. I'm going to get this, going to drop a ball there so you can see what happens from the get-go. But you can see that the ball rolls in, falls through, and it's all set up. Nice little thing. So this can be used all across the board if you want to create walkways in your map, if you want to create all sorts of interesting things. It could be piping throughout the environment that you don't want to have to custom model and instead put in the hands of your level artist. There's plenty of times that this is going to be very useful. So always keep in mind that it's something that's very easy to create and leverage from. So we're gradually getting through this now. However, the next thing for us to look at is going to be creating a drop target set. So essentially a set of letters that exist within the world that sit along some sort of rail. When each letter is taken out, they eventually give you a multiplier to your overall score from that point on. So the player's aim is going to be to knock down each of these letters. Now, I'm going to use this as a good opportunity to teach you about child actors, which is a great way for us to basically create one actor that can, in its construction script, generate many other actors that will then be placed within the world. So what we're going to do that is we're first off going to create a variable band that is a simple blueprint that will have a starting position, an ending position, and a band between the two. At which point we're then going to have, after the variable band is created, a single drop target created, which is going to be a single object that has a letter on it. And then we're going to create a drop target set, which will be a blueprint that is based upon variable band that will basically create a variable band. You type in a word and it will then automatically create drop targets to the size of that word along its frame. So let's begin. Now the first step that we're going to have is we're going to need to import some assets. And what I'm going to do at this point is I'm going to implement the assets that are called SM post half. And the other one that I'm going to need to make sure that this works is SM band extender. So I'm just going to click on SM post half, and I'm going to scroll up to SM band extender, control click. I'm then just going to drag those two into import all. Default tier should be fine. I'm just going to double click and check that the collision on this asset is fine. That should be correct. And also I'm going to go to my band extender and view collision. That'll actually be fine because we never expect the ball to go up or in between these, so that's totally fine. So from here on in, we're going to go to blueprints. I'm going to right click and we're going to create ourselves a new blueprint actor. Now this blueprint actor is essentially going to be running a construction script that will create two ends and then a piece between the two of them. So I'm going to create a new actor, and I'm just going to call this BP underscore variable band. Let's open it up. And now, once it's up, let's have a look at what we have here. So at the moment, there's no asset here. It's just the default scene route. So I'm going to add a static mesh component. And this is going to be called post 1. So post 1 is going to be set to post half, at which point you'll have this. I'm going to compile, save, and then I'm going to go to my construction script. Now within my construction script, what we want to do is we want to essentially have a location in the world that is going to be the post location. We're then going to set post 1's rotation to face that location. We're then going to add a static mesh at that location, which will be the secondary post. And then finally, we're going to add a static mesh that will stretch between the two of them, that will be the band itself. So the first part there is going to be for us to add a variable that will be called post location, and it's going to be a vector. Compile, save. Now this vector is going to be set so that it can be editable, and as well as that, I'm going to show the 3D widget. Finally, I think I'll set the X to be by default 200. Compile, save. Now if I look at what that looks like in the world now, I can drag this in, and you'll see that we have this nice little post location widget here. And I can drag it around, although right now it won't do anything, but that's okay. So the next element is going to be getting this asset, post 1, getting post location, which is the area that we want to work with, where the new post will be created, and essentially all we're going to be doing is set rotation of post 1. You can see that one is called set relative rotation, at which point I'm going to simply drag off of post 1, get relative location, and then there's a nice little function called find look at rotation, and I'm going to connect that to post location. So it's going to find the rotation that is required to look between this position and this position. And if I was to then connect this to here, compile, save, you'll notice that now in the world, wherever I put this part of the widget, this is always going to face it. Do you see how that's rotating to face our actor? So that's the first step. Now that we've done that, we're going to create a new static mesh component. So I'm going to right click and add static mesh component, at which point the relative transform is going to be equal to the post location, and the rotation by default is going to be set up as an opposite of this find look at rotation. So I'm going to get my relative transform, and what I'm going to do is I'm going to drag off of it and type in the word make. Now it needs a few things here. First off, we have a location, which is easy, so I'm going to connect post location to the location. The next section is it's going to require a rotation, so I'm going to get my find look at rotation, but this time instead of looking from the relative location of post 1 to the post location, I'm going to do it the other way around because we're going to be looking backwards. So I'm going to get this, and I'm just going to duplicate these so it's just a little bit cleaner in the graph. Connect those two, and I'm just going to set that as a rotation. So with those two in mind, compile, save. If I was to look at my viewport, we're missing one thing. And what we're missing here is we don't actually have the mesh set. So while I could set this mesh manually by clicking here and then just plugging it in, I think it's a good idea for us to make sure that the two posts always match one another. So I'm going to drag in a reference to post 1, and off of the static mesh component, I'm going to type in set static mesh. at which point I'm going to connect this to the mesh of post 1. Post 1 is a static mesh component reference. So I need to drag off of that and say get static mesh to find the actual mesh involved. And now, upon connecting those, compile, save, you'll notice that we now have a post here and a post here, and in between them we have nothingness, but they're actually facing one another. So wherever I move this widget to, it's going to automatically face home, which is exactly what we want. So how do we put the band between them? Well, that's rather simple. If I was to look at the band extender, you can see with how this is set up in the world that this comes directly from here. And what that means is we can actually do an offset directly from that location. So we can add the band extender in and automatically just stretch it across. I'll show you how that's going to work in just a moment. So within variable bend, what we're going to do is we're going to once again add a static mesh component. So I'm going to right click, add static mesh component. I'm going to connect these two up. And all I'm going to do here is I'm going to set this. I know I do want this to always be the band. So I'm going to just set it to band extender. Now its relative transform is going to be the same transform as post 1. So I'm going to get this, drag it in, and I'm just going to say get relative transform. So now that that's set, what I'm going to do is I know band extender is exactly 100 units long. So from here to here is 100 units, which means at a scale of 1 on the x-axis, it is 100 units long, which allows me to do the math backwards to work out what scale it would need to be to connect the two locations. And that's actually rather simple math here. All I need to do is get the static mesh component, and I need to set the relative scale 3D. And the scale is going to be equal to the Y and Z scale. So I'm going to drag off of this transform and just do a break. And I'm going to split the scale, and I'm going to split this scale as well. Now the reason I'm doing this is when I set the scale here, I want my Y scale and my Z scale to be exactly what I had them set as. However, I want my X scale to be equal to, this is where the math comes in, it's going to be equal to post 1's relative location, so that relative location, minus, so vector minus vector, the post location. So by getting those two and subtracting one from the other, and then getting the length, oops, not get path length, get vector length, it actually tells me how long the distance is, like how far the distance is between those two locations. I'm just going to add some reroute nodes here so I can make this a little bit neater. And because that tells me the distance, all I need to do is divide that by 100, which we know is equal to a scale of 1, and connect it to here. Now, compile, save, and if I look at this, you can now see that wherever I put this asset, it's automatically extending the band between those two locations, which is fantastic. The final thing that I need to do here to make everything okay is to simply go into the actual assets themselves and set them up to be just a little bit prettier. So I'm going to open up the band extender. I'm just going to set it to be white, save. I'm also going to set post half to be equal to, we can see what each of these are if we're not sure, remember that, so I can go highlight this. So that's the main base. I'm going to tell this to be blue. I'm going to tell this to be white, same as the other asset, so simple white. And finally, I'm going to tell this section here to be simple metal, which is the cap. Save, and now if I see them in the world, I have a rather simple asset that we've just created that will automatically suit itself to the situation. Now the next element is going to be adding the child actors to the variable band to automatically place themselves along this line here. So we've gone and we've created a nice simple variable actor, the variable band, and it's time that we now create the drop targets that we're eventually going to align along this. So the drop target's rather simple to create, but the first element of this is we need to, as always, import the mesh. So I'm going to open up my files, and I'm just going to get sm_drop target and pop it into here. Import. So we've got our drop target. I know from the beginning that I want this to just be simple white plastic. Doesn't have to be amazing. Save. So we've got ourselves the basic mesh. Let's go to blueprints. Let's right click and let's create ourselves a new blueprint class. And it's going to be an actor called BP_drop target. So the drop target is going to be relatively simple. It's going to have a couple of little things though that we need to really consider. Now the first thing is we need to set ourselves up with a function that will drop the target and a function that will reset the target. So that's rather simple. First off, I'm going to add a component which is going to be a static mesh. I'm not going to set it to be the root, it's just going to be sitting above the root, and it's going to be called DT mesh, which stands for drop target mesh. So I'm going to set that up as my drop target mesh, compile save. And all I'm going to do here is I'm going to right click, create a custom event, and this is going to be called drop. After the drop event, I'm going to go custom event, and this is going to be called reset target. So I'm going to just take a shot in the dark with how I want these to function. I'm going to drag in DT mesh, and I'm going to drag off that and type move component, and I'm going to use the move component to function. And this is going to be rather straightforward. All we're going to do is when we want to drop it, we're going to say move. We're going to move component to -110 on the Z axis. I'm going to ignore X and Y for the time being because we just want it to go straight down. Next thing I'm going to do as a safety precaution is I'm going to set the collision enabled to be no collision. So I'm going to plug that in. Now next up we're going to have a play sound at location. So we'll play ourselves just a simple little sound effect every time it drops as well. So I'm going to right click, play sound at location, which is just going to be, the location is going to be the actor location. And the sound effect is going to be, for the time being, let's just play the bumper hit effect so we've got something. Eventually we'll switch that out to be its own unique thing. For reset target, it's going to be substantially more straightforward. I'm just going to set this to move to 0. So that's a completely standard thing, all set to 0. And finally, to get this functioning, I'm going to tell it that event hit. So when I get hit, I want to drop. Now, one of the things that we want to always check whenever we use hit is just make sure how our collision is set up. Now, in this case, we have block wall dynamic is checked, but we have one thing that is not, which is simulation generates hit events. So make sure you check that. Compile, save. So that's under collision if you can't see it. At this point, we now have a drop target that will theoretically drop and then, reset itself. But let's quickly test that. On begin play, I'm just going to add a delay. And after 1 second, it's going to drop. And then I'm going to add a delay again, which after 1 second is going to reset. So compile save. And if I go to my viewport and I hit simulate, so now that we've told it to reset, and this is going up to XYZ on the 0, the next thing we need to do, that's very easy to mess up in this situation, is make sure that DT mesh is actually connected to your component here. If you're copying and pasting, it's very easy to leave that component reference empty. And of course, now that we're doing that, the other thing that we need to do is, in the same way over here that we set the collision to be no collision, I'm going to duplicate that, and I'm going to set the collision on this to now just say collision enabled again. So that should be a correct reset. So we're going to test that by setting a delay node off of begin play, which is going to have drop, delay, reset. So if I go to my viewport and I hit simulate, I can see after 1 second it goes down, and then after 1 second it goes back up. So we should be all good now for that to function. Now, with that working, I know that there are things that we're going to need to do later. I'm just going to make you aware of that now. At the moment, the target's not reporting anything to anyone to work out whether it's dropped or not, but that's okay. I'll show you how to do that in just a little bit. The thing that we need to set up though from here is our lettering, such that we have a character that is floating just in front of this. So I'm just going to add a component, and that component is going to be text render. Now by default, I'm going to get this text, and I'm going to set this text to say the letter U. So getting this text set up correctly just requires us to essentially kind of move this around until we've got something that really works. So I can see where the character is right now. I'm going to rotate this to be in 90 degrees on the Z axis. So it's now there. I'm also going to move it just a little bit in front. So 25 centimeters on the Y axis puts it there. I'm going to set the horizontal alignment to be equal to center. This way it's in the middle there. And now I'm just going to turn the size of it up to something that I think will work. So I'm going to try 5 and 5. Which looks okay. Yeah, 5 and 5 seem like good values for our X scale and Y scale. So that can be our basic character that sits there.